Okay, this is our FRQ Topic 8, and to get started on this, we just did our review on horizontal and vertical motion, and for this topic, we're doing motion along a curve, parametric and vector motion. So I have this sheet that compares these two types of motions. It's on our Google Classroom, so you can go and print out a copy of this, or just look at it there if you like. But it has a lot of good information, just things that you need to know. Some of them are basic things that you already know, but some of them are things that we learned when we were doing it, when we were covering this unit in full, and it'll be good for you to go back and review. Okay? But let's go ahead and get started on some examples, and as we're going, we'll be using a lot of those formulas that are on that sheet. So I'd like to begin with number 1 from your worksheet packet. Do this as notes for you. Okay, this was from 2016 from the BC test. It was with a calculator. Many of these are with a calculator. And remember, when you're using a calculator for these, always try to, in for y1, put x prime of t, in for y2, put y prime of t. Okay, those are the two great, you always want to put the two velocities in, all right, the two parts of the velocity. In for y3, if you like, you can put the square root of y1 squared plus y2 squared, because that's often used as well in a couple of those formulas from our sheet there. This comes into play. Okay, this is the equation for speed. All right, and if you want total distance traveled, you need the absolute value, the integral of the absolute value of this. Okay, so anyway, keep that in mind. In for y4, I like to put 0 just in case we need to see where something is crosses the t-axis or the x-axis. All right, so in this problem, we have the position of the particle in the xy plane. They give us dx dt, so I'm going to put that in for y1. And it says the graph of y consisting of 3 line segments is shown at the figure on the right. So they do not give us dy dt, but they give us dx dt. So I'm going to go ahead and put that in for y1. Let me clear out everything that's in here. I had a bunch of stuff in here. Okay, so I'm going to put x squared plus sine of 3x squared. Double check, make sure it's good. You're good. All right, I'm going to just get rid of that. So we won't need to put the y2 in for this problem, but in general, that's what I do if I can, if possible. Okay, so then it says at time 0, the particle is at position 5, 1. Okay, that means that x at 0 is 5 and y at 0 is 1, right? Because that's the x coordinate and the y coordinate at time 0. Okay. Part A, find the position at time 3. Okay, well, we have a point, and so we can find the position at any other point if we know something about the velocities, right, the derivatives. We explicitly know dx dt, and since we are given this graph of y, we can get information about dy dt from the graph. So we're going to set up 2 fundamental theorems here. Well, if we need to, 2 fundamental theorems. So x at time 3, x at 3 minus x at 0 is equal to the integral from 0 to 3 of x prime, like that. They gave us x prime, so x at 3 will be 5, which is x of 0, plus the integral from 0 to 3 of x prime, which we are given. So x at 3 is, back to my calculator, 5 plus integral 0 to 3 y1 14.377. So the x-coordinate at time 3 is 14.377. For the y-coordinate, let's see, for the y-coordinate, they actually give us the graph of y. So y at 3, I can just go and look on the graph. Y at 3 is this value of y, right? So this value of y has got to be a negative 1/2 because they told me that these are line segments, and so that has to be a negative 1/2 right there. So y of 3 is negative 1/2 from the graph. So at time equals 3, the position is 14.377, negative 1/2. I like to give them a response in the same form that they gave me information. So if they gave it to me as a point like this, I like to give it back to them as a point. Okay? This part of the problem was worth 3 points. 1 point for the integral, 1 point for uses initial condition. That's something that they like to do on any fundamental theorem problem, and then 1 point for the answer. Okay, part B, find the slope of the line tangent to the path when time is 3. We need to know something about slope of the line tangent. Slope of the line tangent is always dy dx, always. I don't care if you're in function mode, parametric mode, polar mode, slope is always dy dx. So if we are in parametric mode, dy dx is dy dt over dx dt. And I'm sure once I write that, you all will remember that. But maybe up until then you didn't. Okay. It's on that sheet, that little review sheet that I talked about, but while you're doing problems, you'll learn these, you'll review these as you go on when you're doing problems. So we need the slope at time 3, so I'm going to, for notation's sake, I'm going to say at time 3 here, and then at time 3 here. So I need dy dt at time 3 divided by dx dt at time 3, right? dx dt at time 3 will be easy to get. I just plug in 3 for t. dy dt, I have the graph of y, and I need the slope of y at time 3. I need the slope at time 3. Well, this slope, dy dt at 3, is up 1 over 2, right? So 1/2. That slope is 1/2. And then dx dt at time 3 is just, I'm going to put 3 in for time here. So that will be 3 squared plus sine of 3 times 3 squared, so that's 27. And that would be a safe stop spot. If you can't stand it and you want to go get a decimal, go get a decimal, but that's a safe stop spot. So I think I'm just going to leave it like that, okay, for this problem. That was worth 1 point just for the slope, the answer. Okay. Part C, find the speed of the particle at time 3. So we need to know that speed is the absolute value, it's the magnitude. I'm going to write it like we wrote it last. This is how we wrote it for horizontal and vertical motion. The difference now is that the velocity is not a single value. The velocity is a vector. And so all of a sudden, instead of the absolute value of some function, we have the absolute value or the magnitude of a vector. So this is this is the square root of x prime of t squared plus y prime of t squared. When we developed that, when we were going over this unit for the first time, we developed that looking at the Pythagorean theorem. Okay, that's where that came from. All right, so we want the speed at time 3. Speed at time 3, so a little notation here. Velocity at time 3. This at time 3. Okay. Well, at time 3, this will be x prime of 3. I can use my calculator to get that. For y prime at 3, I can go and look at my graph. Y prime at 3, well, I found that up here. That was my 1/2, right? So this will be 1/2 squared. And now I can go and use my calculator. So the square root of x prime of 3 squared, right? X prime is stored into my y1. That's x prime. So here I can put y1 of 3, and then I forgot to square it, so let me go back and insert a parentheses because I want to square that. So that's the velocity, that's the x prime at 3 squared, plus 1/2 squared is 1/4, right? So that gives me the speed at time 3, so 9.969. This part of the problem was worth 2 points. 1 point for the expression for speed. So just knowing the formula got you that point. And then 1 point for your answer. And then the last part of this problem, find the total distance traveled by the particle from time 0 to time 2. Another formula, total distance traveled. So total distance traveled from 0 to 2, it is an integral. It's the integral of the speed. It's the integral of the absolute value of velocity, which is speed, right? So I'm going to write this out. So x prime of t squared plus y prime of t squared dt. Okay. Now usually this is just a straight calculator problem, but in this case it's not, because we don't have an exact expression for y prime, right? So I'm going to go look at my graph of y from 0 to 2. My graph of y from 0 to 2. So I'm ignoring anything bigger than 2. Y prime just has 2 different values here. From 0 to 1, y prime is -2. And from 1 to 2, y prime is 0. So for this integral, I need to split that integral up into 2 pieces. One from 0 to 1 and one from 0 to 2. And for each of those pieces, I'll put the appropriate y prime in. So integral 0 to 1 of x prime of t squared plus, so that part for that section y prime, the slope was a -2, down 2 over 1. So -2 squared dt. So there's that first piece. And now for the second piece, from 1 to 2, x prime of t squared plus, remember that slope there was 0 for that section, so y prime is just 0 there. And now this can go into your calculator. Okay, so we've got Math 9, 0 to 1, square root. Okay, y prime squared, I'm sorry, x prime squared, that's our y1, so y1 squared plus negative 2 squared is 4 dx, so that's the first integral, plus, here comes our second integral, math 9, 1 to 2, square root, y1 squared again, plus 0 dx. So 4.350 or 4.349 are both accepted. So I like to round, so 4.350 is the total distance traveled by that particle. This part of the problem was worth 3 points. 1 point for the expression for distance. So again, just knowing that formula, distance, just knowing the formula. 1 point for the two integrals. And then 1 point for the answer. Okay, next up I'd like to take a look at the problem from 2012. So let's go look at that one. Okay, problem from 2012. So for time greater than 0, a particle moves along a curve so that this is its position. At time 2, the particle is at position 1, 5. So x at 2 is 1 and y at 2 is 5, right? And they gave us x prime and y prime. So in my calculator, I'm going to go put x prime and y prime in for y1 and y2. So x prime is this one. I always check and make sure. And then y prime is sine squared of t. Remember, that means you have to take sine of t and square it, right? And in for y3, I'm going to put the square root of y1 squared plus y2 squared. And then I have that in there. That will help me when I'm doing total distance and speed and things like that. So, and then I think I'm going to go ahead and put 0 in case I need it. Okay. Part A. Is the horizontal movement of the particle to the left or the right at time 2? Explain your answer. And then find the slope of the path of the particle at time 2. So a bit going on here. First of all, is the horizontal movement to the left or the right at time 2? Horizontal movement is just the movement in the x direction, right? So I need to look at my x prime and at time 2, and I'm just asking myself, is that positive or negative? And quite honestly, I can just look at, if I put 2 in for t, the top is positive, e is always positive, e to any exponent is always positive, so I know it's going to be positive. But let's tell AP that we know what we're doing and not just doing everything in our head, right? So at time 2, dx dt is equal to square root of 4 over e squared, right? Which is greater than 0. Therefore, the horizontal movement at time 2 is to the right. If x prime is positive, the particle moves to the right. If x prime is negative, the particle moves to the left. That's the same as with horizontal and vertical motion as well, right? Okay, so we took care of the first part, and now it says find the slope of the path of the particle at time 2. Find the slope. So slope is always dy dx, always. whether you're in function, parametric, or polar. But dy dx, if you are in parametric, is dy dt over dx dt. Makes sense. Makes sense algebraically as well. So at time 2, good notation here, at time 2, we need y prime at 2 over x prime at 2, and I can use my calculator for that, right? Because y prime is stored in for y2 and x prime is stored in for y1. So I need y prime at 2 divided by x prime at 2. And this will be the slope, 3.055. Okay, so this part of the problem was worth 3 points. 1 point for moving right with reason, with our reason. 1 point for considers dy dt over dx dt. We always have to show what we're doing, right? Always show what we're doing. You could have written that as y prime of t over x prime of t, and that's fine too, all right? But you have to show what you're doing. And then 1 point for the slope at time 2. Okay, part B. Find the x-coordinate of the position at time 4. We have the x-coordinate at time 2, and we have x prime, so simple fundamental theorem of calculus problem. X at time 4 minus x at time 2 is the integral from 2 to 4 of x prime. So x at time 4 is equal to 1, because x of 2 is 1, plus the integral 2 to 4 of x prime. We don't have to rewrite the function for x prime because they gave us the function for x prime, so we don't have to rewrite that. So 1 plus math 9, 2 to 4 of x prime, which is my y1, right? Oops, I actually hit enter again. Dx. There we go. So 1.253 or 1.252. This part of the problem was worth 2 points. 1 point for the integral, 1 point for the answer. This time, in this fundamental theorem problem, they did not just give us credit for using the initial condition. Oftentimes they do that. Part C, find the speed of the particle. Speed of the particle at time 4, and then find the acceleration vector. It's a vector of the particle at time 4. Okay, so speed at time 4, speed at time 4 will be the magnitude of the velocity vector at time 4, right? It's the absolute value of velocity, but velocity is a vector in a parametric equation. So this is the square root of x prime at 4 squared plus y prime at 4 squared. Okay, so to our calculator. Now this is, we have, and for y3, we have x prime squared plus y prime squared. So all we have to do is evaluate y3 at time 4, right? So I'm going to go y3 at 4, and that's going to be my answer, 0.574 or 0.575 if you round. And then the acceleration vector at time 4. For the acceleration vector at time 4, that's equal to, it's a vector, it's equal to the velocity vector, x double prime at time 4, y double prime at time 4, right? So that means it's the derivative of x prime at time 4 and then the derivative of y prime at time 4. So I'm going to find first for the x double prime, I'm going to find the derivative of y1 at time 4. That'll be my x-coordinate of the acceleration vector. And then same thing, except in place of y1 I'm going to put y2, and that will be the y-coordinate. So x-coordinate, y-coordinate of this vector. So negative 0.041 and then positive 0.989. Okay, this part of the problem was worth 2 points, 1 point for the speed, 1 point for the acceleration. I think only 1 L. Okay, the biggest problem I see students make here is not showing where numbers come from. You will not get credit for your acceleration if you don't say where it came from. Even if it's correct, you won't get that point if you don't say where it comes from. Okay? You won't get this point if you don't show where it comes from. You have to show what you're doing to get these values. Never put down some decimal without saying how you got it. Never. Okay? Part D, find the distance traveled, total distance traveled. So distance traveled, or total distance traveled, from time 2 to time 4 is the integral from 2 to 4 of the magnitude of velocity of that square root. dt. Okay? So by saying that, I'm saying what I'm doing to get this. Now for us, we have this square root stored in for y3, so I'm just going to take the integral from 2 to 4 of y3. Working on it. So 0.651, or you could write 0.650 there. And that was worth 2 points. 1 point for the integral, 1 point for the answer. Okay? The last example I'd like to do with you is the one from, I think I picked out 2010, the one from 2010. So let's go over to that one. We have a particle moving along a curve, again, where x is equal to this function, which is easy to take a derivative of, and y is not explicitly given. Both x and y are in meters, so they might be asking us for units. We'll have to watch out for that. And t is measured in seconds. It is known that dy dt is equal to this function. So in your calculator, remember that we always like to put x prime and y prime in for y1 and y2 respectively. So I'm going to put x prime in for y1. X prime is 2t minus 4, right? And in for y2, I'm putting this function they gave us. So t e to the t minus 3 minus 1. So carefully make sure that you put it in right. And I'm just leaving the rest of the stuff in here in case we need it. I know I'll need y3. I don't know if I'll need the 0 or not, but there we go. Okay. Find the speed of the, by the way, since I'm doing that, I'm going to go ahead and tell AP that I know what dx dt is. I'm going to say that up here. dx dt is 2t minus 4. And now I can use y prime, x prime, dy dt, dx dt. I can use all of that because I've told AP what that is. I can't use dx dt here if I haven't said what it is yet. Okay? First of all, find the speed at time 3. Speed at time 3. That's your square root of x prime of 3 squared plus y prime of 3 squared. And now we have x prime and y prime in our calculator, and we have in for y3, we still have that square root, right? So this is just y3 at 3. So y3 at 3. 2.828. This was just worth 1 point for the answer. Okay. Part B, find the total distance traveled by the particle for 0 to 4. Total distance traveled from 0 to 4 is the integral 0 to 4 of the speed equation. So x prime of t squared plus y prime of t squared. Okay, so math 9, 0 to 4 of y3 dt. So the total distance traveled, 11.588 or 587. This part was worth 2 points, 1 point for the integral, 1 point for the answer. Part C, find the time from 0 to 4 when the line tangent to the path of the particle is horizontal. When the line tangent is horizontal. Well, line tangent is horizontal. That means the slope is 0, right? So I'm going to say that. Tangent line is horizontal when dy dx equals 0. The slope is 0. Now dy dx is 0 when so I want to say that. So dy dx, which is dy dt over dx dt, that is 0 when dy dt is 0, right? When the numerator is 0, the slope will be 0. And dy dt is 0 at t equals, so I'm going to set just dy dt equal to 0 and find that time. So on your y equals, I'm going to turn off the graph for y1. I'm going to turn off the graph for that square root. I'm going to leave y prime and I'm going to leave my 0. Okay? And I only want to look at 0 to 4. So window 0 to 4. And I just need to include 0 in my y's, so I'm just going to leave it like that. So dy dt is 0 at that time, right? So second calc 5, enter, enter, enter. So at time 2.208 or 207. Okay? So I found the time where the path of the tangent line to the path of the particle was horizontal. Is the direction of the particle, of the motion of the particle, to the left or to the right at that time? Okay, well, direction of the particle horizontally only deals with x prime, right? So dx dt, which I already told them I knew what that was. I had to tell them that for both of these other parts as well. dx dt at that time is, okay, let's go find it. So at that time right here, I want to find what dx dt is. So back on your home screen, right now your calculator thinks x is that time. If you want to, you can store that in for a or b or whatever, but right now your calculator thinks x is that time, the value of x. I want y1 at that time, so I'm just going to type it in like that. Again, if you want to store that in for a or something and then put a here, that's fine too. But your calculator does think that x is that number right now, so that's what it's going to do. So this is 0.416. This tells AP I did type it in and I got a number there. That is greater than 0. Okay, that is greater than 0, which means the movement of the particle at time 2.208 is to the right, because the dx dt was positive. I gave a reason because of that. Okay, this part of the problem was worth 3 points. 1 point for considers dy dx. Okay, I had to consider dy dx, so this was important, you guys. Writing that was important there. Okay, writing this was important. Okay, tell AP your thought process. You're communicating that you know the process, not just the answer. Act like you're explaining it to somebody who doesn't know a whole lot about this. 1 point was given for that time, and then 1 point was given for the direction of motion with the reason. Okay, part D here. There is a point with x coordinate 5 through which the particle passes twice. Find each of the following. So back up to our problem. This was our equation for x, which is a parabola, right? Just x is a parabola. And they're saying that there is a point with x coordinate 5 through which the particle passes twice. So that means there are two places where this curve goes through 5, right? So first of all, find each of the following, the two values of t when that occurs. So I'm going to take my equation for x, which they give me, and I'm going to set that equal to 5, because that's what they told me to do. And I just find the two t values. Can this be factored? Let's see. It can. How about that? So at time 1 and time 3, the x coordinate will be 5. Okay? So that, by the way, got me 1 point. Okay? Part 2 of part D. The slopes of the line tangent to the particle. Oh, find each of the following. The slopes of the line tangent to the particle's path at that point. So I need to find the slope at each of those points, right? So I need to find dy dx at time 1, and I need to find dy dx at time 3, right? So dy dx at time 1 is dy dt over dx dt, both at time 1. Okay? Back to my calculator, because again, I still have those equations in for my y1 and y2. So, but just remember, dy dt is my y2, is our y2 that we have stored in here. So I need I need y2 at time 1 divided by y1 at time 1. So 0.432. And then we're going to do the same thing for time 3. So I'm going to just scroll up, grab that I just put in, change the 1s to 3s, and I'll be in good shape. Oh, there's just 1. How about that? Okay, this was worth just 1 point for both slopes. Part 3 of Part D, the y-coordinate, find the y-coordinate of that point, given that y of 2 is 3 plus 1 over e. Okay, so let's see. Were we given an initial point here? Were we given an initial point? Oh, I'm sorry, the y-coordinate. Oh, yes, well, we're given an initial point right here. So we want the y-coordinate at either time 1 or time 3 here, okay? There's a point with x-coordinate 5 through which the particle passes twice. Okay, so I think my question is, will those be the same? Is the point at time 1 the same as the point at time 3? And the answer is yes, they're the same, because it says that this particle passes through that point twice. Okay, but if you don't trust that, then it won't take you too long to just find both of them, and you'll see that they are the same. Okay, so since they're the same, I'm going to set up the first fundamental theorem. I think I'm going to use this one with the 1 here. So the time 3. So the y-coordinate at time 3 minus the y-coordinate at time 2 is equal to the integral from 2 to 3 of y prime, first fundamental theorem. So the y-coordinate at time 3 is equal to y of 2, which they give us, plus that integral, which is, so 3 plus 1 over e plus math 9, 2 to 3. Y prime is my y2, right? So y2 dt. So that turned out to be 4. And if you wanted to, you could go and find out that y of 1 is the same. Y at time 1 will be the same value. It'll be 4 as well. This was worth just 1 point for that y-coordinate. Okay, now it's your turn. Go and try some on your own.